So as you can see, we're going to start this one off on Daily Lessons, page 106. And there's a couple of things that I want you to see. So this is the graph of f double prime. Or not really the graph, but we're talking about this function f double prime. So the second derivative. So I want to know, what is its relationship to f of x? So f double prime is all about concavity. Is it concave up or concave down? So if f double prime is greater than 0, if you're thinking about something being positive, it's being happy. So f of x is concave up. Notice it could be decreasing, it could be increasing, decreasing here, increasing here, but concave up. Likewise, if f double prime is negative, excuse me, f of x, oh, so sad, it's down, concave down. If f double prime is changing from positive to negative, so it's changing from concave up to concave down, this place where it's changing from positive to negative, is called a point of inflection. You were introduced to that really, really briefly on the quiz last unit, but we will spend lots more time on this. Negative to positive, I'm going to go, oh, so sad, it's down to up. That place is still a point of inflection. So if I go up here and I want to figure out if f double prime is 0 or undefined, what holds true? Well, just like in f prime, when f prime is 0 or undefined, you would get a critical value. It's the same thing, but this is a possible point of inflection. And to be sure, you would say f prime is changing from negative to positive or positive to negative. You can see over here, though, I've got f prime. So this is the slope of the slope. It's the second derivative, which means it's the first derivative of this function, of f prime. So all their same relationships, like where f prime, if f prime was positive, that means f of x was increasing. Here, if f double prime is positive, that means f prime is increasing. If f double prime is negative, that means f prime is decreasing. Positive to negative, that'd be increasing, decreasing, so there is a relative max. Decreasing, increasing would be a relative min. So we're looking at more than one graph now, and more than one equation. 0 undefined, it's a horizontal tangent with a possible min or max. So it could possibly be relative min or max. So on here it's saying, on the previous page you found the first derivative of this function. And we can go through our work, but I can also just get it out and show you. Maybe. Oh, there it is. So this is what we did on the previous page. Well, on page 104, it wasn't quite previous, 2 back. And we figured out this was the derivative. What we're going to do now is we're going to find f double prime. By the way, this is 2 over 3. This is what this is right here. So f double prime. Again, I don't really want to rewrite this. So I'm going to say f prime, be sure to label, is the same thing as 2/3 x plus 2 to the negative 1/3 power. That means f double prime be negative 1/3 times 2/3. So I have negative 2/9. I leave the inside alone. My new exponent, it would take negative 1/3 minus 1. So I get negative 4/3 times the derivative of the inside, which is just 1. So f double prime of x be negative 2/9 x plus 2 to the 4/3 power. So what you're doing next then is you're figuring out, okay, well, where are the critical values? It says perform a sign analysis. That's like when we make the chart. Sorry, I have a cough. I can see the derivative. The numerator can't be 0. So I'm setting the denominator equal to 0 to see when the second derivative does not exist. If I divide both sides by 9, take both sides to the 3/4 power, I'm still going to get 0 is equal to x plus 2. And I get x is equal to negative 2. If I make a chart, here's x, and I have f double prime this time. Negative infinity to negative 2. And negative 2, I knew that f double prime does not exist, which is nice because f prime didn't exist, so you can't possibly have a second derivative that exists if the first derivative doesn't. Negative 2 to infinity. Take a value from here, negative infinity and negative 2. How about negative 10? Negative 10 plus 2 would be a negative. But then I have a negative and I take the cube root and then take it to the 4th power. Anything because this 4th power, the denominator is going to be 0. Or I'm sorry, not 0. I'm getting pretty tired. The denominator is going to be positive. You're taking something to the 4th power. But I have this numerator that's negative. So every single thing I can put in here is going to be a negative divided by positive. So both of these are negative. Then it says determine the intervals of concavity. So based on what I just did up here, f double prime was negative. That means f of x is concave down. F of x is concave down. And it would be on the interval. I'm going to run out of room. Negative infinity to negative 2. And 2 to infinity as f double prime is less than 0. So I could say f of x is never concave up as f double prime is never greater than 0. It says points of inflection. There's no place on here where f of x changes, or where f double prime changes from positive to negative or vice versa. So none of those things are true. If I had more room and I wasn't writing in a big marker big enough for you to see, I would probably write that down. So here though, if I look on the previous page, and I'm thinking negative. Negative is concave down, right? If this is f of x. If I go back to my graph, see how here it kind of looks like part of a frown? That's concave down, resulting in a sharp turn, and that's why the derivative doesn't exist. So, moving right along. This one says for each of the following functions, determine the intervals where the graph is concave up, concave down, and determine points of inflection. So, concave up, concave down, I'm going to find the first derivative. And then do it again to find the second derivative. Set this equal to 0. I can factor out a 12x. And I can see x equals 0, x equals 2. So when I'm making my chart, f double prime, sorry, negative infinity to 0, 0 to 2, 2 to infinity. And I know f double prime is 0 because I just set this equal to 0, and that's how I got those values in the first place. I'm taking a value between negative infinity and 0, so negative 10. 12 times negative 10 would be negative. Negative 10 minus negative 2 would be negative, so negative times negative is positive. Between 0 and 2, if I put in 1, 12 times 1 is positive, 1 minus 2, no, negative. Positive 10, positive, positive, positive. Because I'm going to run out of room, I'm I'm going to say f is concave up. Negative infinity to 0. 2 to infinity as f prime. F is concave down. 0 to 2 as f prime of x. And then I would also say there's a point of inflection right here and here at x equals 0 as f prime is changing, or in this case f double prime changes signs. So positive to negative or negative to positive. Okay, on this one, pause the video if you need to find the derivative. But I'm going to tell you that g prime, I can't resist. G prime ends up being, so once I take this and I simplify, and I don't want to use all the room in my box, but negative 1 times 6 would be negative 6. Leave the inside alone. You have negative 2 exponent. When you simplify, you should get negative 12x divided by x squared plus 3 squared. Once you find that, you can find g double prime. So, oh, did I just do all this wrong? I don't know. We're good. I was looking at a different place, and so we're good because this is the same thing as on a few pages ago, where we did the function and we tried to figure out what was increasing, decreasing. So here's g prime. I'm sorry, my throat really hurts. What I need to do then is find g double prime. You would have to do the quotient rule, so bottom derivative top minus top derivative bottom over the bottom squared. But because that's going to take up most of my room, I'm going to tell you when you simplify, you end up getting this. It takes some work to get to that point, but it also would take up a whole lot of my space. I'll put this under here for a second. You can see I wrote in pencil. And it's kind of hard to read. There's a whole lot going on. So, if I set the numerator equal to 0, I can see here that I'm going to get, divide both sides by 36, I get 0 is equal to x squared minus 1, add 1, take the square root, but you introduced it. Well, I did, so x equals 1 and x equals negative 1. The denominator has another situation going on like before where it can't ever be 0 because x squared is always going to be positive, plus 3 is going to make it positive also. So it can't. So when I make my chart, just these values go in. Oops. I can tell I'm getting super tired because my work is not all that great. Negative 1, and then I'm going to go negative 1 to 1. Then I'm going to use this paper over here because I can. Sorry, I want to try to go sideways. Negative 1 to 1. Make sure I'm still on the screen. Negative infinity, negative 1, negative 1, negative 1 to 1. And then I'm going to go 1, 1 to infinity. So I'm going to put this over here. And if you go through the sign chart, so putting in a value of each, you should get positive, negative, positive again. And you can stop, make sure that you get that same thing. I can see from negative infinity to negative 1, and from 1 to infinity, f double prime is greater than 0, which means f is concave up. Negative 1 to 1, f double prime is less than 0, so f is concave down. there's also going to be point of inflection at x equals -1 and x equals 1. And the reason why, as f double prime, or in this case I should say g double prime, oh man guys, I just noticed these are all that, g's all around, as g double prime changes signs, meaning positive to negative or negative to positive. Okay, so that's it so far, and then we're going to save the second derivative test for one more video.